Okay, right. So in today's session, we're moving forward from moles. So you've done moles. I'm going to recap moles. I'm going to show you how I do it in my head. Um, Most of you managed to get the first sheet from last time done. So, and some of you've managed to get the, aspects of the second sheet done. So we're going to do two things. All right. So we're going to recap a little bit on molar mass, moles and mass. And then we're going to work on Avogadro's constant and stuff. So that's the entire plan. Let's get everybody else in who's just turned up a tad bit late. There we go. So let's go through it. Let's look at what we did and how it relates to today's work. I'm just going to delete that so we've got kind of today's work like this. All right, so everything is to do with moles. So as I teach chemistry, I always write on the top, let's make this big. You can never, oopsie daisy, that's supposed to be big. You can never compare mass. And for you guys, mass, it should always be in chemistry in grams. Physics, it's kilograms, chemistry, it's grams. You can never compare mass at all, ever. You can only compare moles. You can only compare moles. And as we do more and more work, you'll see what I mean. And I'm spending a lot of time on moles because I think it's such an important part of chemistry. All right, so what are moles and how do we work them out? I'm just zooming out to see if we have got a periodic table. We haven't, and we're going to have to get it. Okay, so moles, and the way to calculate moles from last lesson, moles equals mass in grams divided by relative molecular mass, relative formula mass, relative atomic mass, call it what you want. All right? It has many, many different names. And the thing for me is irrelevant to what you call it. You are simply using the big number in the periodic table. There's a point of chemistry when you've got to understand what it is. I get that. But this is calculations and this is using things. And the other advice I always give is always use the periodic table from your exam board. I'm going to assume you're all going to do something like AQA at Excel or something, so the layout's generally the same. When you get older, you won't know yet. So here's the periodic table. And I'm going to put that periodic table here. And you are going to need it. All right, so how do I work out moles? And this should be a recap. The step-by-step here, all right, is how to find the molar mass, the relative molecular mass, the MR, or relative formula mass, okay? And we're going to start with water. I like using water because it uses some simple elements and it uses something that we know quite well. So as much as I've written the steps there, I'm going to tell you what happens in my head. And I'm going to kind of give you an example. I've got 36 grams of water. How many moles is this? Well, this is your mass. So you go to your equation and go, well, I want to work out my moles. And something that I do is I write N, and for number of moles, instead of writing the whole moles things out. Mass in grams, 36, divided by relative molecular mass or molar mass. Well, water is H2O. It's got two H's and one oxygen. You go to your periodic table, you go, aha, I wonder what H is. It's hydrogen. Ooh, you look at the big number at the top. That's just one. Hydrogen is the simplest. N equals 36 over 1 plus 1. I'm substituting 1 for H's because I found out H's were 1. And my oxygen, I'm going to substitute there. I'm zooming to oxygen. There it is, the big number 16. Plus 16. 16 add 1 is 18. The number of moles is 36 divided by 18, which is 2. So this should be a recap, all right? Okay, but I want to do more than that. I want to talk about Avogadro. And I put his picture up here last time. Avogadro was, Just a dude, absolutely amazing. Born in Italy in 1776. I mean, this is a long time ago. What 300 years ago? And what he worked out was that in 1 mole of anything, it doesn't matter what it is, if I calculate 1 mole of something, it contains exactly 6.022. I work in standard form. I'm not sure if you've done it in maths yet, but you can literally just put it into your calculator. It's an easy way of writing a very big number. 6.022 times 10 to the power of 23. This is the Avogadro constant. This is how many atoms, how many molecules, how many particles you have in 1 mole of anything. So I can work out the total number of particles in anything. Well, how would you do that? Well, here we have 36 grams of water. And the number of moles, so I'm going to write this out. The number of moles of water is equal to 2. The number of particles, in this case molecules of water in 2 moles, right? The way you would work this out is you take your number of moles, 2, right? You do 2 times the Avogadro constant, 6.022 times 10 to the 23. Okay. And you should get an answer of something like 1.204, oh no, 1.244 times 10 to the power of 24. Right. But you don't try to do it in your head like me, you use a calculator and do it. Okay, 24. This is the total number of particles in 36 grams, total number of molecules in 36 grams of water. So, to formally write this out, you take your number of moles and times by 6.022 times 10 to the power, this one we use the umlaut, 23. That's it. Right? This is a big jump, year 9. I'm adding, more work to it. So the first thing you're going to do is start off very simply, calculate the MR of these things. I've already done water, and that was 18. You can do the rest of them, right? And then here is the easy questions. How to calculate the number of atoms, number of particles. All right, I can tell you that's going to be 1.244 times 10 to the 24, but you better check. You better calculate it yourself. Oh, I'm getting old. That hurt my head. All right, so try it. I'm going to convert this. I know it's a big jump in what we've been doing. I'm going to stop this recording now.